Today we'll be talking about different types of steps in organic chemistry. We'll be talking about two specific types of steps which will represent both of them through arrows. One of them is a synthetic step, so we're talking about a transformation of one type of molecule to another by adding different types of reagents, versus a mechanistic step where we're really trying to explain how a molecule, through molecular collisions, leads to a different product. Okay, so first of all, we're going to talk about synthetic steps. Okay, so synthesis problems are very commonly asked in organic chemistry. So we might be given this sort of problem here. We start with one type of alkyl halide, and we're asked to design a synthesis to turn the starting material into the product. We're allowed to add reagents at will. Okay, so we might imagine a sort of synthetic scheme where we start with the alkyl halide. Okay, then we're going to add in hot sodium methoxide here. Okay, we're going to add in hot sodium methoxide. We're going to actually add this into a reaction flask. Okay, then we're going to generate the alkene. Okay, from that alkene, we can then isolate it. Maybe we're going to do an extraction. Maybe we will do distillation or recrystallization if our product is a solid. And then finally, we're going to take that isolated solid and add in HBr to get our final product over here. Okay. Each of these steps here, the sodium methoxide step, the HBr step, each of them we might leave for maybe 30 minutes, sometimes maybe an hour or two, sometimes overnight. So each of these synthetic steps, we're really looking at hours, maybe minutes, but certainly not anything shorter than minutes. So each of these synthetic steps involves someone coming in and adding a reagent, mixing stuff together. So this is timescale of minutes to hours. Okay. Each intermediate, if we're lucky, we don't have to do much purification, but in many cases, we might need to, say, take the alkene, do an extraction of it. Maybe we would have to do a distillation or something along those lines. Okay, so synthetic steps, each one is actually a person or maybe a robot if we're lucky on a synthesizer, but there's some kind of intervention externally. We're adding things, we're changing temperatures, we're actually doing things. At each arrow, we have to step in and do something. Okay, mechanistic steps on the other hand, it's a little bit tricky because they also use arrows that look almost exactly the same. Okay, the arrows we use in a mechanistic step look almost the same as they do in a synthetic step. But in a mechanism problem, we're asked to explain a transformation. So for instance, we might be given a question of draw a mechanism to explain the transformation of the alcohol starting material to the alkyl halide product here. Okay, so this would be most likely a SN1 reaction. So we might draw initially protonation of the alcohol by HBr, give us an oxonium and a halide anion. The water will pop off as a leaving group, giving us a carbocation, undergoes a rearrangement, which finally would react with the halide anion to give us the final product here. Okay, each of those little steps, each of those little arrows there, represents some sort of molecular collision, molecular interaction. Okay, so when we're talking about mechanistic steps, these don't require an intervention. No one needs to step in and add HBr or remove the water or add in the halide. These are all just floating around. We're just saying, here is a molecular collision, say between the alcohol up here and the HBr down there. And that leads to protonation of the alcohol to make a better leaving group. So when we're talking about mechanistic steps, these happen really quickly. They happen on the timescale of seconds, maybe even less than seconds, milliseconds perhaps, or microseconds. And no one needs to come in here. So for one molecule to start as an alcohol and turn into an alkyl halide, that could take maybe just a couple of seconds there, maybe even less than a second. So that's the key thing to keep in mind when you're looking at mechanistic steps versus synthetic steps, is These synthetic steps, often you need to step in, leave something for an hour or two. Mechanistic steps, these happen really quickly. No one needs to step in and say add the halide at this point here. The other thing to keep in mind is that even though one molecule might transform in less than a second, they all start at different times. Some molecules start right when you turn on the hot plate. They start their transformation almost immediately. But if you have 1 mole of starting material you want to turn into product, some of them may not start until 30 minutes in or 50 minutes in. They all start at different times, kind of like a marathon with 1,000 people. They're going to stagger the start times for those people. Same way molecules start at different times. They might only take a millisecond to turn from starting material to product, but they might sit around doing nothing for 45 minutes. Okay, so hopefully that clarifies a bit about mechanistic steps versus synthetic steps. So thank you for listening.